Hello everyone. The topic for today's lecture is conditionals. Before I get started with today's lecture, I want to go through a few quick announcements. Exam 1 will be held on 22nd Feb via Canvas. It will be a 2-hour exam. You'll be provided a 24-hour window period within which you can take the exam at your own convenient time. The 24-hour window period will begin at 11:59 p.m. Madison time on 21st Feb and it will end at 11:59 p.m. Madison time on 22nd Feb. If you're unable to take the exam during this 24-hour window period, please make sure to go fill out the Exam 1 conflict form at least by next week Wednesday, which is 17th Feb. Exam 1 conflict form link is available on the course website. You need to go to Tools and then click on Class Surveys to find the Exam 1 conflict form. If you haven't already signed up for Piazza, please pause the lecture video here and sign up right away. That's because Piazza enrollment is part of the 1% communication grade for this course. Let's do a quick recap with respect to where we are in the topic of control flow. Control flow is all about which line of code are we executing currently, which line of code are we going to execute next, and so on. The main concept in control flow is in-order execution, which means that each line of code will be executed exactly once in the order in which that line comes within the program. There are three exceptions for in-order execution. Functions are the first exception. Functions are a tricky exception because the execution will directly jump from the line where you're calling the function to the line where you have defined the function, which could be anywhere above the line where you're calling the function. We spent a week understanding the concepts of functions. The next two lectures are going to cover the topic of conditionals. Conditionals are the second exception for in-order execution. Conditionals enable you to run some part of your code when the condition is satisfied and some other part of your code when the condition is not satisfied. Following the two lectures covering conditionals, we are going to spend two lectures understanding the concept of loops. Loops are the third exception for in-order execution. That will cover all the topics under control flow. Exam 1 will include all the topics under control flow, which will include Feb 19th lecture. Let me give you a quick overview of the learning objectives for today's lecture. In today's lecture, we are going to learn the concept of conditionals and the associated syntax. We'll be learning a lot of terminologies like conditional execution, alternate execution, chained and nested conditionals. We are going to understand what is meant by blocks of code. The reading for this topic is chapter 5 of Downey book. Please skip the recursion section for now. You also have interactive exercises for today's lecture. Please make sure to go through those. The rest of this video will cover a review for the topic of functions. We are going to go through two review problems. I would encourage all of you to pause the lecture video, go through the problems on your own, and then come back and watch the rest of the lecture video. Here is problem number 1. Please pause the lecture video here and go through this code snippet. Then leave a comment in the comment section stating what do you think is the output of this particular code snippet. If you were thinking the output would be A, B, E, F, C, D, then you had the correct answer. Let's try to understand why this program outputs these characters in the provided order. Please pay close attention to the fact that the print function call for displaying C and D are indented within the function definition. The lines of code inside a function definition will not be executed unless you're explicitly calling the function. where are we calling this function? That's the last line of this program, correct? We are invoking print underscore letters function there. So the characters C and D gets printed last. That's because the last line of the program is the function call. How do we know the other print function calls are not part of the function definition? That's because the print function calls for A and B are not indented, so they are outside any function definition. So those will get printed first. The print function calls for E and F are also not indented, so they are also outside any function definition. Those are going to get executed next. And finally, you have the function invocation for print underscore letters. So you're going to get C and D as the output. We use indentation to let Python know that certain lines of code are inside the function and the rest of the lines of code are outside the function. The code inside the function is often called as a block of code. We'll cover other blocks of code types as part of today's lecture. Python doesn't really care about vertical space or any extra horizontal space within an expression or things like that, but it really cares about the fact that you use tab space for indentation for a particular block of code. Here is review problem 2 for you. Let me give you a quick overview about this problem and then you can pause the lecture video to go through it on your own. We have three function definitions here for h, g and f, and we have the variables x and y all over the place. Clearly this problem is testing your understanding of frames and argument passing. So please pause the lecture video here and draw the frame for each function call so that you can keep track of the local variables while keeping track of the global variables within the global frame. I've already set up a Word document here which has the outline for the global and the local frames for the function calls. How many frames are going to be there for function calls as part of this particular program? That would be 3 frames for the 3 function calls and 1 frame for the global frame, correct? Let's first fill in the values inside the global variables of x and y. X has a value of 10 and y has a value of 20. So I'm going to fill those in within the global frame. The first function call here is for the f function. What sort of arguments are we passing here? Those are positional, correct? How can I say that? That's because I don't have a parameter name associated with the function call here. So recall that positional arguments line up with the corresponding parameters. Do not get confused with the global variables x and y with the local variables x and y. The local variables x and y are the parameters for the function f. Recall that parameters are nothing but special variables, so they also go into the function frame. Since arguments line up with the corresponding parameters, argument y is going to line up with parameter x. Y has a value of 20, so x will have a value of 20 within the f frame. X has a value of 10, so y is going to have a value of 10 within the function call frame for f function here. What are we doing next? We are printing x and y. So we are going to get 20 and 10 as the display out of the first print function call here. What are we doing next? We are calling the g function. What sort of arguments do we have here? We have named keyword arguments. That's because I'm saying parameter name x equal to argument x. So you might be wondering x equal to x. Well, that's very obvious. But the x here before the equal to sign refers to the local variable within the g function call frame, and the x after the equal to sign refers to the local variable x within the f function call frame. So the x on the right hand side of this assignment operator is the argument. The x on the left hand side is the parameter. So please don't get confused here. So what are we passing to the g function call here? For the parameter x, we are passing x as the argument. The argument is coming from the f function call frame. So x is going to contain 20. For the parameter y, we are incrementing the value of the local variable y by 1. So you're going to be passing 11 to the y variable within the g function call frame. So the g function call here, the g function here calls the print function to display x and y. So you're going to get 20 and 11 as the next output. What are we doing next? We are calling the h function. Notice that we only have one argument. That means that we are going to fall back to default value. Where can you find default value of a parameter? That is included as part of the function definition itself. The one argument that we have here for the h function call is positional. So always positional arguments line up with the corresponding parameter. So y is going to line up with the parameter x here. There is no way in Python for you to directly pass the argument that you provide here into the second parameter without having mentioned the first argument which goes into the first parameter. So y here, which is the argument, is going to line up with x. Y has a value of 11 in g, so x is going to have a value of 11 here. What's going to happen to the parameter y with an h function call frame? That's going to take the default value of 2. So now when you call the print function inside the h function, you're going to get the display as 11 and 2, and that will be the output of this program. I would encourage all of you to try out both of these programs using Python Tutor. You can just type in the lines of code for review problem 1 and review problem 2 to confirm that you got the correct output. This would be the best approach that you can follow. Go through the problem using pen and paper, understand the code snippet, then try to confirm your mental model by using Python Tutor. I'll wrap up this video here. In the next video, we'll learn about conditional.